Good morning, students. So, I welcome you in the lecture of electronic devices and circuits. So, in this lecture, we will discuss about the power amplifier. So, what exactly mean by power amplifier? That concept we will discuss today. So, this topic is very important as far as your exam point of view is concerned, as far as knowledge point of view is concerned. So, stay on, stay tuned. So, the definition. So we know that the small signal amplifier, what are the amplifiers we have discussed by using different biasing technique, are the small signal amplifier which we are using for amplification. Then we are using its linearity, that is nothing but the input and output are the linear one, and the gain. Okay, the factors main are the amplification gain. Gain is nothing but what output by input itself. So we are considering these main factors, that is the amplification, linearity, and gain also. But as far as the large signal amplifier is there or power amplifier is there, the voltage and current levels are larger as compared to the normal small signal amplifier. So we have to consider these three parameters. That is nothing but the efficiency, then what is the maximum power handling capacity, the impedance matching to the output device. So normally, whatever the power amplifier is there, that is in the last stage of any amplifier. In the first stage, there is nothing but the transducer. We are using mic at the input side. Then we are feeding that input of mic to the small signal amplifier, and from the small signal amplifier, we are feeding the signal to the large signal amplifier, and at last we are feeding that signal to the loudspeaker itself. So this is the overall block diagram. We can say that block diagram of any amplifier system. So the power amplifier is the second last stage before the output. We were feeding output to the loudspeaker. So we have to see what are the consideration of power amplifier and how its significance of this system. So types of power amplifiers we will discuss. Types are class A amplifier, class B amplifier, class AB amplifier, class C and class D only. So these are the only five types are there. This is the very important concept. Okay, you have to listen very carefully to what is the types of power amplifiers and how to discuss it. So class A amplifier is there. So class A amplifier conducts full 360 degree of input. That is nothing but full input and output. The positive half cycle and negative half cycle it will conduct from the cycle, and Q point is the middle of the loop. And you have to remember this very carefully, that this amplifier, class A amplifier, conduct full 360 degree, and the Q point is at the center of the DC loop line. Then the class B amplifier, it will conduct only half cycle, that is nothing but the 180 degree of input. Only the half cycle will conduct, and Q point is at the cutoff region. The Q point is there. I will show by using diagram. Don't worry about this. How 180 degree and how viewpoint region is there. I will explain in detail in the upcoming slides for you. So it will conduct what 180 degree of input cycle, and Q point is the cutoff. Then the third is nothing but the class AB amplifier. In the class AB amplifier, it compromises between A and B. That is nothing but the greater than 180 and less than 360 degree conduction is there, and cut off in between mid of cut points over there. That is I will explain over there. So class C amplifier, it will conduct less than 180 degree, and the Q point is located at below the cutoff region. So in the cutoff region, the Q point exists, and in the D class D amplifier, the curve. This amplifier is based on the special for digital signal. Digital signal, for this we are using class D. Especially you have to remember these four categories, that is class A, class B, class AB, and class C over there. Okay. So we will discuss one by one. In the class A amplifier, as we know that it will conduct full 360 degree, that is nothing but the positive as well as negative conduction over there, and the Q point is at the center of the DC load line. Q point is at the center of DC load line. Okay, so in the class B amplifier, it will conduct only positive half cycle. Why is it so? Because the Q point is at the in between this cutoff region. Okay, here you will find the cutoff. Here this is the saturation region, and this is the middle one here. Okay, where amplification will conduct. So the Q point is at this point only. Q point is at this point only. So due to that, it will happen only positive cycle will be conducted. Okay, class AB amplifier. In the class AB amplifier, what will happen? It is a combination of class A and B, in which the Q point is at this point. Normally, in the A, you will find the Q point at this end of red line, and in the B, you will find a Q point at this one. So, what will happen? Due to this, the conduction is in greater than 180 and less than 360 degrees. So, in between 180 and 360 degrees of input cycle will happen over there. In the class AB amplifier. In the class C amplifier, what will happen? The Q point is at in between, not in the Q, in the cutoff region. So, what will happen? The conduction of the AC is less than 180 degrees. Less than 180 degrees. Will happen. Okay, the efficiency, we will see comparison of efficiency over there. So, comparison we will see. Okay, so comparison in the class A, that is nothing but a 360-degree conduction is there. Due to that, power efficiency is 25 to 50% over there. You will find the power efficiency is there. In the class AB, 180 to 360 conduction is there. So between efficiency is between 25%, 50%, and 75%. That is nothing but the 25 to 78.5%. You will find the efficiency over there. And class AB, you will find 180 degree. Sorry, class A B. You will conduction is 180 degree and highest efficiency you will find over there. That is nothing but 78.5 as compared to this AB, class A, class B, class AB, and class C over there. And in the class C amplifier, the conduction is less than 180 degree. Class C is not usually delivering large amount of power, thus efficiency is not given here. So efficiency is very less, so it is not over there. And digitized operation, whatever the digitized operation, that is on-off operation is there. So we are using the class D over there. So efficiency is typically 90%, 95%, or 90% over there. So efficiency, what exactly mean by that is nothing but the output by input power over there. So the lower amount of conduction of amplifier, higher the efficiency. That is the what you can say. Its meaning, that is nothing but here you will find lower conduction, that is nothing but the 180 degrees. So you will find a more number of efficiency over there. So as far as class A amplifier is there, class A amplifier we will see in this lecture. Class A we will finish. Okay. Yeah, class A we will see, and after that we will see class B in the next lecture. So here, so as far as class A amplifier is there, there are two types we can say that. That is nothing but the series fed class A amplifier. Okay, series fed class A amplifier and transformer coupled amplifier. So here in the series fed, we are using just normal our this structure over there, this diagram over there. And in the power transformer coupled amplifier, you will find the transformer at the output over there. So due to this, what will happen? The efficiency, what will happen in this case? The structure will be bulky because we are using transformer in this case. So series fed we will see. In series fed we will see. This is a simple. We can say that our fixed uh, divider biasing technique is a fixed divider bias. So RC, this is nothing but my load over there. So due to RC, the current constant flow is IC, and then I am using the base resistance that causes to current flow, that is nothing but my IP over there. And we are using power transistor. So this is my input. Here I am taking the output. This is my DC. Okay, this is a DC, and here VI is nothing but my AC over there. So I am using this thing. So as we know that this Q point is at the center of list. So this is my input waveform. Okay, input waveform. Here I am giving here IC is obtained. So AC IC current is like this, and whatever my voltage we see, output voltage current is nothing but my this one. So due to that, you will find a 360-degree conduction of both input and output voltage and current over there. Voltage and current over there. So this is the significance of Q point. If Q point is there, so this waveform will be shifted to upside and downside if we are shifting my Q point like this one. If my shifting Q point at this point, then what will happen? Only positive half cycle will conduct and negative half cycle will go to the cutoff region over there, like this one. if I'm pointing at this point, Q point at this point. So if this waveform will be shifted to bottom side and this negative will be vanished, and here also the negative waveform will be vanished there. So this is so now input power. So input power, if we am seeing about this waveform, so input power is given by PI of DC is nothing but the VCC into IC. We know that P is equal to power is equal to voltage in current. So what is the input? VCC, and IC is nothing but the input over there. So if I multiply this one, I will get the input power. So output power is calculated by, that is nothing but the V square C RMS value, its RMS value, or divided by RC. We know that voltage power is equal to VI also there, and if I am placing the value of I is equal to V by R, so V square by RC, I will get in the output power. So output power is given by this one. So if I am placing the peak to peak, so instead of RMS, so I have to write VC peak to peak divided by 8 RC over there. Efficiency is nothing but output power divided by input power. So if I am placing this one, output AC divided by input DC. Here he has the DC voltage. Here is something wrong here. DC voltage VI DC into 100. I will get the efficiency over there. The second case is nothing but my transformer couple amplifier. The transformer couple is what? So we will stop at this stage. Okay. Transformer couple. So transformer couple here, in this case we are using just the transformer in the output stage. So the ratio of here the voltage is V1, here voltage is V2, and the N1 and N2 are the turns ratio over there. Turns ratio, that the V2 is nothing but my output voltage, that is nothing but the VO itself. And RL is connected across the secondary winding of the transformer. Remaining waveform is the same. So voltage ratio we know that voltage ratio V2 by V1 is directly proportional to N2 by N1. That is nothing but the output turns ratio divided by input turns ratio over there. So V2 output divided by input is equal to nothing but N2 divided by N1. That is nothing but the turns ratio of the output divided by turns ratio of the input. But similarly, in the current, the case is reversal. So I2 divided by I1 is nothing but the N1 divided by N2 over there. So impedance ratio, that is nothing but the RL dash over there. RL dash divided by RL is equal to R1 by R2. R1 by R2 is nothing but the N1 first turns ratio divided by second turns ratio, its square equal to A1. Okay, so this formula you have to remember. So I will explain these things to you. So we are keeping the micro point at the center of DC line. That's what will happen. The current swing is like this one. There is nothing but my collector current over there. The current it will conduct full 180-degree waveform, and in the output cycle with the voltage, you will find the whole current conduction will be carried out in the output current over there. Okay. So I think we will stop over there. Thank you very much for this lecture. Thank you.